9.1 Similar right triangles. In this section, we discuss similar right triangles. When the altitude is drawn to the hypotenuse in a right triangle, it forms two other right triangles that are similar to the original triangle. There is a right triangle on the left side, and another right triangle on the right side. And these two new right triangles are similar to the original triangle that you started with. And so you could use properties of similar right triangles to write problems and find missing pieces. But this is a very difficult way to work these problems. We'll learn that when you have this situation with the right triangle and an altitude drawn to the hypotenuse, that we could use the idea of geometric means instead to solve this type of problem. Identify your pieces. This is your altitude. Your hypotenuse. And then you have two legs. We're going to call this leg A, and the leg on the other side, leg B. Now, when you have this right triangle with the altitude drawn to the hypotenuse, there are three pieces of this triangle that can be used as a geometric mean. The altitude can be used as a geometric mean. Leg A can be used as a geometric mean. And leg B can be used as a geometric mean. Now, these are the pieces that can be used as a geometric mean. You just need to know what they are the geometric mean of. Let's label the two parts of the hypotenuse. We'll label this side C and this side of the hypotenuse D. When the altitude is used as a geometric mean, you use the two pieces of the hypotenuse. So piece C would go here and piece D here. When you use a leg as a geometric mean, we're using leg A first. So when we're using leg A as a geometric mean, we need the length of the entire hypotenuse. So we would put C plus D here. Also on the other leg, we need the entire hypotenuse, C plus D. It's the piece that goes in the last position that we need to be very careful and make sure we use the correct piece. When you're using leg A, you need to make sure to use the piece of the hypotenuse adjacent to leg A, which would be piece C. When you're using leg B as the geometric mean, you need to make sure to use the piece adjacent to leg B. The piece of the hypotenuse adjacent to leg B would be piece D. So you have your three geometric mean problems. Now let's look at an actual problem. In this problem, we do have a right triangle. With the altitude drawn to the hypotenuse. Identify the pieces that you can use as a geometric mean. Remember, you can use your altitude as a geometric mean. Your altitude is this piece that's labeled 20. So 20 may be used as a geometric mean. You also have two legs, Y and Z, and each of those may be used as a geometric mean. When you use 20 as the geometric mean, the altitude, remember the altitude is the geometric mean of the two pieces of the hypotenuse. The two pieces of the hypotenuse would be x and 12. To solve this proportion problem, cross multiply 12 times x would be equal to 20 times 20. Simplify, 12x would be equal to 400. Divide both sides by 12. X is approximately equal to 33.33, and the 3's just keep going. We want to round to one decimal place in this section, so you would look at the second decimal to decide, do you round up or do you keep the tenths place? You only round up, remember, if it's 5 or higher, so this would stay 33.3, and we're done with x. Let's move on to y. Y is a leg on the right triangle, and we've already determined that we could use it as a geometric mean. Remember, when you use a leg as a geometric mean, you must use the entire hypotenuse. We found that this piece of the hypotenuse x was 33.3. We want to know what the entire hypotenuse is, so we would add 33.3 plus the 12 and determine that the entire hypotenuse is 45.3. So we would use the entire hypotenuse, 45.3, but then because we are using leg y, we need to determine what's the piece adjacent to leg y. This is leg y, this is the piece adjacent, so the piece is 33.3, this would be our adjacent piece. Now continue to solve. Cross multiply, y times y would be y squared. On the other side, you need 45.3 times your 33.3. So y squared would be equal to 1,508.49. Take the square root of both sides, then y would be equal to the square root of 1,508.49. Square root of 1,508.49 is approximately equal to 38.83. Remember to look at that second decimal place to determine whether you would round up or leave it the same. This would round to 38.8. So y is approximately equal to 38.8. Let's move on to the last leg, leg z. We've already determined that because this was a leg, we could use it as a geometric mean. Remember, when you use a leg as a geometric mean, you need the entire hypotenuse, which we've already found is 45.3. And then you need the piece of the hypotenuse adjacent to the leg, 12. Cross multiply z times z, and 12 times your 45.3. Z squared then would be equal to 543.6. Take the square root of both sides. Z then would be approximately equal to 23.31. Remember to look at that second decimal place to determine whether you would round up or leave it the same. This again would just stay 23.3. There we have it.